Hey, all right, guys, here we are. Oh, man, I am dark. Let's see. There we go, lighten up. Hey, guys, here I am. We are talking about integrating trig functions today. So the table that I'm going to put up here, really, you got to memorize them. Sorry, guys. Got to memorize them. But you know what? If you know trig derivatives, trig integrals aren't too much different because you're just working backwards, okay? So let's take a look at trig integration using trig functions. All right, so here's the table that you need to memorize. So make sure you memorize. These are just the reverse chain rule versions here. Okay, these are just reverse chain rule. But you'll notice that this is just derivative in reverse, right? The co's, generally, not all the co's have a negative. So you got to be careful with that. Okay, so let's take a look here. So it says here, two other rules can be developed by using the identities that tangent x equals sine x cosine x and cotangent x equals cosine sine. So if this was sine x over cosine x dx, then we have a reverse chain rule because the derivative of cosine is negative sine. So I need a negative, and then I have negative ln of cosine x plus c. All right, so the integral of tangent is actually a natural log. Cotangent, same thing, right? Cosine x over sine x dx. And this time I actually don't need a negative. So this is just going to be straight up the ln of the absolute value of sine x plus c. All right, so that's a couple of other ones. If you wanted to memorize those, you can. But you can also just use the property, the identity. All right, let's take a look at some problems here. So let's go and integrate. Okay, so we integrate this. We've got negative 3 sine x. All right, this one should be pretty straightforward. The integral, the antiderivative of sine is negative cosine plus c. Let's just simplify that real quick to 3 cosine x plus c. See, because the derivative of cosine is negative sine. So if I took the derivative of cosine, I have a negative sine times a negative, which will give me the positive sign here. Right? That's kind of how I remember it. All right, number 4. Integral of cosine pi t. So this right here, this is going to be a reverse chain rule. So anytime we have a number or something inside the parentheses for our trig function, that is a reverse chain rule. So let's go ahead and reverse chain rule this bad boy. So we're going to reverse chain rule the inside here. The derivative of that is pi. So we're going to need a pi right here as our hook. And we're going to need a 1 over pi outside. Okay, so now we're going to take that 1 over pi part. We're going to bring it there. And we're going to take the antiderivative of cosine, which is positive sine of pi t plus c. All right, there we go. That's it for that one. Let's try another one here. All right, now we got all kinds of stuff. Anytime we see a trig function and we have something inside that trig function, we're going to look at that inside and see, hey, if I took the derivative of that, is that something that I have outside? It is. Y squared. All we need is a 3, right? So I'm going to go ahead and put a 3 right there and a 1/3 out there to do reverse chain rule. Excuse me, there's my hook. So I'm going to have 1/3. And then what's the antiderivative of secant squared? So to get secant squared, I need to take the derivative of tangent plus c. Boom, done. Pretty straightforward. All right, secant tangent. So what derivative gives me secant tangent? Secant. All right, and there's something inside. So I need to deal with that something inside. It looks like I'm going to do a reverse chain rule. So the derivative of that is 2. So that means I need a 2 right here and a 1/2 outside. Okay, whatever this derivative here is what I need as my hook. So I'm going to have 1/2. What derivative gives me secant tangent? And that's secant. So the antiderivative of secant tangent is secant. 2x plus 1 plus c. Bada boom. Bada, oh, I better not. That may be copyrighted. Bada boom, bada bing. Bada bing, bada boom. So I think for this one, I think I want to change it to look like this first. Cosine 5x over sine 5x squared. Like that. Okay, so we're going to use a bit of reverse chain rule. Let's say that u is sine of 5x. So then the derivative of that, u prime, is going to be 5 times cosine of 5x. That's good. Cosine of 5x is what we want our hook. We already have it. So we just need a 5 to finish off our hook, which means we need a 1/5 there. All right, perfect. So really what we're looking at, here is 1/5 5 cosine 5x, which is my hook, times sine of 5x to the negative second power, right? I'm just going to bring this up to the negative second power. And now I'm going to just do the power rule because I already know this is a reverse chain rule. So I'm going to do 1/5. And the power rule here for integrals, I'm going to have sine of 5x raised to the, we're going to add 1, so negative 1 divided by negative 1 plus c. All right. So you can either leave your answer like that, or if you really had to, because I know some of you are like, I just have to simplify. 1 over 5 sine of 5x plus c, which is negative 1/5 cosecant x plus c. Some of you are like, nah, I'm okay. I'll just do what you have there. That works. Okay, so what's the derivative of tangent? The derivative of tangent, u prime, is secant squared. All right, so this is u prime. This is already our hook. Look at that. Our hook is already there. Hook is already there. So really we're looking at like 1 over u, right? So 1 over u is an ln, so we're going to just have the ln of tangent theta plus c. And that's it. That's all there is to that one. Let's take a look at a few more integration type problems that we might see. So integrate tangent squared x. Now the problem is this one is that we don't have, even if we change this to tangent x dx and we squared this puppy like this, we don't have a hook in here, right? Because u prime is the derivative of u is secant squared. So we won't be able to do anything with that because the derivative tangent is secant squared. We don't have a hook. We don't have a secant already in there or a secant squared already in there. So we're going to have to do something a little different. So sometimes we might have to use a Pythagorean identity or some sort of trig identity in order to do this. So we're going to go and convert this using this trig identity right here. So this is going to be secant squared minus 1 dx. We do know the antiderivative of secant squared. The antiderivative of secant squared is tangent x. And the antiderivative of 1 is just x. And there we go. We got it. All right. So sometimes you might have to use that identity. Let's look at the last one here. Find the area bounded by y equals 2 cosine x, y equals 1/2 tangent x at x equals 0. So we're going to set up an integral and we're going to use a calculator to integrate this. So what I would do is I would set up the calculator to graph this in this interval right here. All right. So let's go ahead and do that. So I'm using a TI Inspire here, and we'll go ahead and graph each of these. So 2 cosine x. You got to make sure that you're in radian mode. And then we'll also graph, 1/2 tangent x. Half tangent x, enter. And we're looking at just this little section right here. So I'm going to go and zoom in. See if I can zoom in here. I'm going to go and zoom box this guy. I love zoom box. I only want to look at this part right there. All right, so this is the picture that we have. All right, this is the what we're looking at there. All right. Okay, so what we're going to need to find is this area right here. Oops. I'll do that. We're going to find this area right in here. All right, so in order to find this area in here, we need to know where they intersect. Because we're finding the area from 0 to the intersection point. And the above function, so the first function we know here is blue, is going to be our cosine x. And so remember, when we're doing our integral, okay, the area is going to be the integral from 0 to, we'll find that point in just a second. The top function, now the top function goes like this, and then our other function was red, it went like this, and we need to find the intersection. Okay, our top function is blue, so our top function was 2 cosine x minus our bottom function, 1/2 tangent x dx. Right, and all we have to do now is find our intersection point. So let's go ahead and find that guy. So the way we do that is we do menu, analyze graph, intersection, click, scroll over. We've got 1.082. So I'll go write that here, 1.082. Now I have the setup. So this is my setup, and I'm going to go ahead and calculate what that area is. All right, so there's various ways you can do that in this. All right, I am going to do it in the calculator. So let me add a new page. Do calculator, and then I'm going to do menu. You could do a few things. You can either click right here, and you've got an integral right here. Okay, an integral with, click that, and all you got to do is type things in. Pretty nice, huh? So 0 over, and then 1.082. We've got 2 times the cosine of x minus 1/2 times the tangent of x, and then dx. 1.387 or 1.388. So we're going to go and put that here, 1.388. Done. Isn't that nice from the TI Inspire? Nice and easy to write that in there. All right. So that's how we find the area bounded by two curves in terms of trig functions. All right. So there you go, guys. We did some trig integration. Just remember that you're going to be using these integral formulas that I went over here for all kinds of different integration types, right? So you can do anything, any type of integration problem that we did before, whether it's area between two curves, area under a curve, or volume, volume, start plus accumulation, any of those types of things that we did with integrating, we're going to also do those with integrating trig functions. All right, so we'll see you next time, guys. Have a good one. Bye.